How are you guys? It's Emil. Today we're going to be going over how to do a simple Pawley refinement for your powder X-ray diffraction data. So firstly, I'm going to head over to JEdit. So this is what I use to edit my files, and it goes right into TOPAS immediately. So what I'm going to do is I'm immediately going to do Control-N. This is going to create a new file. What I'm going to do here is I'm going to save it immediately as well. I'm going to go to the file location. It's going to be this copy file, this copy subdirectory. I know what it's supposed to look like. I'm just going to save it as is. And now I'm going to head over to the TOPAS menus. I'm going to select Simple Pawley Refinement. I'm going to select the data file. And you have to be careful because it could say it won't update the directory that you're currently working in. So you do have to fiddle around with it quite a bit. I'm going to go over forward 11 copy. I'm going to select this XY file, and that's pretty much it. So now you have your setup here. You have the file that it's going to read. You have the zeros. All these backgrounds will pretty much add more parameters to trying to fit your background. You could add more zeros and reduce as you need, and we'll see that as we continue. So now I'm going to add the instrument and the corrections. I'm going to select other diffractometer. My emission profile is going to be CUK alpha 2. I'm going to select that. Now obviously you're going to have to select if you're doing a scintillator or a synchrotron or neutron, however it may need to be, or a monochromator angle, depends what you need, right? But I don't need that. I'm going to stick with this. I'm going to save it. It's going to be an input just like that. So I have my emission profile. You could use variable splits. You could refine your 0 point. We're going to keep that. However, I'm going to comment it out by adding an apostrophe, and I'll leave it for the end. And you can even add the sample height, but I don't need this, so I'm going to do it just like that. So now you're going to select Pawley fit phase. You have your structural information, your phase name. We'll just name it egg, or maybe DYIRSN, as well as your lattice parameters. Maybe it's cubic. You don't really need this per se, but you do have to put in the space group, right? So maybe P2MA or whatever it may be. However, you do have to realize it has to be set like this. Rhombohedral. It's however you want to see it fit. However, I have a particular format that I like to do just because I find it easy. You could see that these gray lines will indicate that it's part of the same one compound, right? So what I'm going to do now is I'm just going to remove this extra fluff, and you can see that information is there. I don't really need it. I find it distracting. Your errors, your do errors is up here as well. This will give you the errors. Of course, we do want that for reporting it in a journal or an article, however it may be. And you can see you could tighten up the convergence criteria further, but this is pretty much fine for me. I'm going to reduce the amount of spaces. Again, I'm very particular with how I like to view this. But now, there is a little bit of information that we do have to include. Again, I like to just put this all at the end. If I'm dealing with a cubic system, A equals B equals C equals, maybe, actually, let me stop with that. Let me show you an example of an actual file that you could refer to. So I will go to 411, and maybe this is cheating, but you'll sort of see the format of what I need. So you could add all of the relevant information right here. So you could see that this is P minus 62M, and I'll explain everything that you need to see. So again, you have all of these relevant sort of variables. So it will say the phase name, it will say the space group. You always need this. You don't. This is optional. However, for note keeping, I like to include it. And also what I'm going to do is I'm going to add an exclamation point next to axial. And this will refine the sort of the how do I explain it? The width peak somewhat, not particularly the width of the peak, but more so the divergence of the base. And I'll show you I'll explain it shortly enough. And you'll get these lattice parameters maybe if you're doing some sort of practice refinement. I know these are going to be correct. However, let me show you sort of a tool that I use to figure out what I need to look like. So this XRD matcher is available on the Online Lab website. I know we have a lot of XRD things, but this is matcher. So we'll be able to put in our experimental XY files and input CIF files immediately. So I'll head over to dropping an XY file. I have quite a bit of files here. And I'll head over to this one. Right, so I know this is going to be my experimental XY file. I'm going to upload that. Sometimes it does take a little bit to load. And you can see it displayed here. Now I'm going to add in the relevant main phase CIF file. And you can see I have quite a bit of a good match. However, you can see not all the peaks are accounted for, intensities are shifted, so this will require rebuild refinement, as well as identification of your other phases with SEM or EDX, however you may want it. And you could add in more CIF files as needed. And you can see oxide's a good match because we're doing this pretty much in open air. So we know what impurities to expect. You can adjust the intensity. And what's even nicer is that you could get a qualitative range of your matched phases. So again, this isn't 100% accurate, of course. It just deals with the intensity here compared to rebuild refinement that will take into a variety of different parameters to tell you the most accurate percentage, right, of your phases. So let's say you want to work with another phase, try to identify it, and you could see this probably isn't relevant, but you could shift the unit cell increase in size will shift it in left, and you could decrease the intensity again. You could shift certain parameters even further, and then you could show it or hide it to compare with a variety of different ones. I believe, to my knowledge, you could handle up to 6 other phases. So I'll drop them all at the same time. You'll see it'll get quite messy. And this all helps you with trying to identify multiple ones at the same time. So you could show, hide, and then when you confirm it's not there, you could just delete them all. You could change the alpha, gamma, beta. All these parameters are able to be changed. So you could download the plot. You could view it. Again, for some quick on-demand results. And you could also generate a Pawley input file. And that goes over your downloads folder. And you could open it, and you could see I've adjusted it to be exactly how I need it to be input, right? So a couple of things to look at here. We create the HKL, the phase name, space group, and we handle all of the repeat variables. If you see PKU here, in a subsequent phase, you need to add some signifier. You need to change the variable. So I like to just add a 1 after. You can see LPA, LPA. When these parameters are the same, they will not be dependent of each other. They will work in the same, be refined in the same manner. You can see sometimes you do have a little bit of error, so there is some user input that's required. If you could see these 3 are the same, it's going to be cubic. Just change this to LPA1. It's not perfect. One day it might be, right? And you have alpha, beta, and gamma, which usually are not to be refined. However, you can do it if you want, right? This is cubic, so we're going to leave it alone. If you see experimental data says this is 119, maybe just throw that in there like that. Otherwise, I'd stick to 120. And I would just copy and paste this right into the file, and it's pretty much ready to go, just as is. So now, we're going to head back over here. I'm going to copy pretty much the same exact thing. So this is 7.4343. because I don't want to be cheating too much here, and then it's 3.89 roughly. And the app will refine it without needing a new variable if it just shows up once. Right, and now you want to handle your oxide case. Your oxide, you will need the space group as well. So we're going to say this is Dy2O3, dysprosium oxide, which is very common oxide. Replace the HKl, you're going to replace the A, B, and C parameters. 10.67, reference. LPA1, LPA1. So these will all refine dependent on each other. I'm not sure if that's the proper terminology there, but just copy and paste. And again, we will have to make sure these variables are different, otherwise TOPAS will throw an error, but TOPAS is usually very good at delegating those errors properly. You don't have to make new labels for your ABC because that's already stored. Again, just these parameters and your dependent or independent parameters here. And again, comment out axial with the exclamation point. We're just going to automatically set it to 10, which means that the peak is going to be quite stiff. So this looks like it's all, actually it's not all good to go. I need to adjust the space group. In the space group for dysprosium oxide, I'm going to check this. You could also check the CIF file. This just is the closest thing that's right here. IA -3. And that's all good to go. So now what I'm going to do is I'm just going to save it. I'm going to update this to TOPAS. I'm going to file, close all. Now I'm just going to press run. And you'll see it refine quite well. So you have your DY, dysprosium, iridium, tin. However, there are some better ways to refine it. So immediately I see that there's, this background, you want it to be as stiff as possible. So if there are no peaks at your lower range, you could always do one thing. You could see now we have all the errors, we have all this information, that's all fine and dandy. You could also do start_x, just like that, and capitalization matters in this case. So we'll do start x12. I know there are no peaks below roughly 13. If you want to start at 13, that works as well. And I'll just show you how that works. So I will upload right here, and I'll run it, and you can see the background works better. However, maybe it doesn't make sense. Maybe you're running a high throughput one. You want to plot a lot of different ones at the same one. Maybe it's just not feasible to start all of them at different values. Maybe you need all of them to start at whatever your standard XRD run is at. So in that case, what I would do is I would just add 10 at the end and re-refine, and we'll see what that gets us. So I do want to save it. I don't want to click no. You'll notice I didn't save it beforehand. I'll add another 0, see how it changes. And the goal is not to just add as many zeros as possible. You want to stop just where it gets right. Because adding more parameters does more harm than foul. I'll add another 0, see how it works. You can see it's really not doing much. I'm going to add another 2 zeros. Go just like this, and you can see there's a little bit of a hump here. So that's going to tell me I added 1 too many zeros. I'm going to revert back. Still 1 too many. So you try your best. Sometimes it doesn't all work out. This is good enough for these purposes. So now you can see everything's pretty much fit quite well. This is just a simple Pawley refinement. Maybe there's another secondary phase, or maybe this is just amorphous, or maybe it's this is the sort of case when axial would help quite a bit, and you'll see that shortly. So now everything's refined quite well. I'm very confident in everything. I'm going to untag 0 error. I'm going to un-exclamation point the 1/by axial. Just going to add an enter here so the matrix doesn't bother me. I'm going to click that again and re-refine. you'll see that the intensities all match up quite a bit. However, this isn't sorted out. So this is something to take caution to later on in the future when you move on to Rietveld refinement. And I'm happy with this. This looks pretty good for a standard Pawley refinement. You'll see the RWP is at 12.28. The lower, the better, I believe. Don't count that on me. And now you can see we've printed out your HKLs, your output file, and if you want all this data, there's another piece of data that works out for when you want to plot. So your observed difference, calculated phases, background. You could save this again. I'm working in the copy directory. However you want to save it, just click this, and now you could head over with those files over to NextRD Refinement Plotter. I'll show you this one. This is also another one that we've developed. You could upload your refinement files, I believe the main txt file, and then your HKLs. So we'll just do these two, and it should work. It'd be very awkward if it didn't. Okay. So now you don't even have to bother with your files. You can see the y-axis limits sort of has to get adjusted. It is what it is. We'll work on that later on and have it look a little better in terms of the GUI. Now, this isn't bad. This isn't a bad starting point. I would decrease the y-axis limits just a little bit. I would shift up your HKLs. Oh, that seems to have been the wrong direction. Okay. So you can see there still needs to be some kinks worked out. Okay, fine. And you can see, you know, this is a pretty good starting point in terms of getting your graph already. It has your HKLs. It has everything labeled out pretty well. Then you can save your plot, and now you have a publication-ready graph. That's pretty much it. I'll update a new video I'll upload a new video where I do a Rietveld refinement and go from there. So yeah, it's a simple Pawley refinement with a handful of tools, XRD Matcher and Refinement Plotter, to make your entire process as seamless as possible. Any comments, queries, concerns, feel free to comment or email me. I'll be more than happy to respond. And if you do send a YouTube comment, or excuse me, leave a YouTube comment, I may not see it. So the best way to get in touch with me is through my email. It's emiljafal.me. Just click this email button and it'll open up a dialog for you to email me. I'll show you what that looks like. It'll be right here. So yeah, appreciate you guys taking the time to watch the video. If this helped, let me know. If it didn't, also let me know. Enjoy the rest of your day.